This video is on section 3.2, proof and perpendicular lines. And there are a couple different theorems that we need to know here. The first one is if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So think about that. If two lines intersect to form a linear pair of congruent angles, so we have two lines that cross each other and they make a straight angle, right? That's what a linear pair is. But those two angles are congruent to each other. Well, then they both have to be 90 degrees. So then if they're both 90 degrees, then the two lines are perpendicular. That's our first theorem. The second theorem, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. If two sides of two adjacent acute angles are perpendicular, then the two angles are complementary. We'll look at that more specifically in class. And then thirdly, if two lines are perpendicular, then they intersect to form four right angles. And intuitively, that just makes sense. We have two lines that cross and are perpendicular. We have four right angles at that intersection. So we're going to start to get into a few more proofs here. So I have an example here of the first one. We have this angle. It appears to be a right angle. We don't know if it is or not yet. And we want to prove the angles 1 and 2 are complementary. So if we look at our given information, it tells us that BA is perpendicular to BC. Well, we know that they're perpendicular, so we can then say eventually that they are right angles because we know that. So we start off the proof by saying that those two perpendicular lines, or those two lines are perpendicular to each other. That's given. Then we can say the angle ABC is a right angle, and that's the definition of perpendicular lines. If we have perpendicular lines, then we have right angles. If we have right angles, then we have perpendicular lines. So that's a definition. Then we can say that the measure is 90 degrees of that angle. That's the definition of a right angle. Again, definition because it's the same forward and backwards. If we have a right angle, then we have a 90-degree angle. If we have an angle that's 90 degrees, then we have a right angle. So then my next step is to say that those two angles, 1 and 2, add up to be angle ABC. Well, that's the angle addition postulate. Two adjacent angles that combine together equal the third bigger angle. Then I'm going to say, because in step 3, I know that the measure of angle ABC is 90. And so I'm going to substitute 90 degrees in for the measure of angle ABC. And that's using the substitution property. Then if the two angles add up to 90 degrees, then by the definition of complementary angles, those two angles are indeed complementary. So make sure that proof is filled in. Then the last thing that they talk about in this particular section of the book is a two-column proof versus a paragraph proof versus a flow proof. And probably 99% of the time you're going to write a two-column proof. Most people prefer to do that. However, you can write a paragraph proof where you write this part out that we have in our two columns as a paragraph, somewhat like your POWs that you write. And then the third type of proof is a flow proof, and that's where we make a flow chart. Those last two are not very common at all. However, they do exist. They can be used. I will not require you to use one versus the other. I typically will keep everything as a two-column proof, but I do want you to understand and know that there are additional types of proofs that you could write. If you want to do all your proofs as paragraph proofs, then go right ahead. On tests and quizzes, though, I will just require two-column proofs. Okay, that's all I have for you for tonight. I hope you enjoy your evening. I will see you tomorrow.